The pressurization system on the A320 normally operates automatically to adjust the cabin altitude and rate of change of altitude to ensure maximum passenger comfort and safety. The pressurized areas are the cockpit, the avionics bay, the cabin, and the cargo compartments. The concept of the system is simple. Air is supplied from the air conditioning packs to the pressurized areas. An outflow valve is used to regulate the amount of air allowed to escape from the pressurized areas. Automatic control of the outflow valve is provided by two cabin pressure controllers. Each controller has an electric motor to move the outflow valve. A controller-motor combination is known as a system. Only one system will operate at any one time, with the other system acting as backup. A third motor is installed for use in the event of both automatic systems failing, and requires a manual input to open or close the outflow valve. To avoid excessive cabin differential pressure, safety valves are installed. Let us look at the operation of the outflow valve for an aircraft in cruise and what happens to cabin differential pressure, cabin altitude, and cabin vertical speed. We will start with cabin differential pressure. If the outflow valve is closed or only allowing a small amount of air to escape, then the cabin differential pressure will increase. Now let's look at what happens to cabin altitude. If the outflow valve is closed or only allowing a small amount of air to escape, then the cabin altitude will descend. We can also see what the cabin is doing by reference to vertical speed. When the outflow valve closes, the cabin altitude will decrease, negative vertical speed. If the outflow valve is fully open, a lot of air is allowed to escape. The cabin pressure will decrease. The cabin altitude will climb, positive vertical speed. The crew can monitor all cabin pressure functions on the ECAM cabin pressure page. Let's look at the information associated with the pressurization system that is presented on the cabin pressure page. The pack indication is displayed green when the associated pack is on. The outflow valve position can be monitored and the system controller in use is shown. There is a single indication for the safety valves. We will look at how this indication changes in the abnormal operation module. The cabin differential pressure, or delta P, shows the difference in PSI between the cabin pressure and external pressure. This differential pressure will be at 0 on the ground and increase as the aircraft climbs. The cabin vertical speed shows the rate of change in feet per minute of cabin altitude. For passenger comfort, the pressurization system will aim to keep this rate of change as small as possible. The cabin altitude is also shown. The vent, inlet, and extract indications are associated with the avionics ventilation system and will be discussed in a separate module. On the ECAM cruise page, there are indications of cabin differential pressure, cabin vertical speed, cabin altitude. There is also an indication of cabin vertical speed on the ECAM door page. Note that this indication is only displayed when the aircraft is airborne. On the overhead panel, there is a cabin pressure panel containing controls to operate the pressurization system. Under normal conditions, no pilot action is required on this panel during flight. The pressurization mode select switch has two settings: automatic and manual. The normal position for this switch is lights out. In this position, the pressurization system is in automatic mode. The use of manual mode and the manual vertical speed control will be discussed in the abnormal operation module. The landing elevation selector normally remains in the auto position. Landing elevation, which is required by the pressurization system, is then provided by the FMGS based upon elevation of the destination airport. If the landing elevation is not available from the FMGS, then it can be set manually using this selector. You will use this selector in the abnormal operation modules. The guarded ditching switch is provided to close all valves below the waterline so that the aircraft can be sealed in the unlikely event of a ditching. We will now look at the normal operation of the pressurization system. As part of your pre-flight walk-around, you should visually check the outflow valve for damage and obstruction. As part of your pre-flight cockpit scan, verify on the cabin pressure panel that the mode selector switch is in the auto position, lights out. Confirm that the landing elevation selector is set to automatic. Landing elevation is then provided by the FMGS based upon elevation of the destination airport. Also confirm that the ditching switch is in the off position, lights out. On the ECAM cabin pressure page, confirm that the landing elevation indication is auto. Once the destination airport has been entered into the FMGS, the destination landing elevation is displayed. Notice that there are no amber indications. So that you can get a better understanding of how the pressurization system works, we will go through a normal flight profile, paying particular attention to the ECAM indications. When the aircraft is on the ground before the flight, the outflow valve is fully open. There is no differential pressure and there is no vertical speed. We can also notice that the cabin altitude is indicating the field elevation of the departure airfield. During the takeoff roll, the system controller signals the outflow valve to close slightly in order to pre-pressurize the aircraft. This is to avoid a pressure surge at rotation. At liftoff, the controller initiates the climb phase and cabin altitude varies according to a fixed law, taking into account the actual rate of climb of the aircraft. The outflow valve will move as required to achieve this. Once established in cruise, the cabin altitude and differential pressure will remain steady. The outflow valve will move as required to maintain the cabin altitude. In the example shown, the aircraft is in cruise at 35,000 feet. Notice the values of differential pressure and cabin altitude. While in flight, we can monitor all the major pressurization indications on the ECAM cruise page. During the descent phase, the pressure rate is optimized so that the cabin reaches landing field pressure just prior to landing. Note, for passenger comfort, the automatic function will limit the rate of cabin descent to a maximum of approximately 750 feet per minute. At touchdown, the cabin altitude should be at the airfield elevation, and there should be no differential pressure. To ensure this, just after landing, the outflow valve is fully opened by the system controller. Once the outflow valve is fully open, an automatic changeover of the system controllers occurs in preparation for the next flight. This happens so that both systems are used equally. This is an example of an abnormal procedure. We will use a cabin pressure fault where one of the two automatic systems fails. At this time, the aircraft is in cruise and all systems are functioning normally. You are the pilot non-flying. When the ECAM system detects a failure, the appropriate caution is generated and the ECAM cabin pressure system page is automatically called. Due to the fact that this is only a crew awareness, there was no master caution. The failure message is red. In the case of a cabin pressure system 1 fault, there is no action required by the crew. System 2 is automatically activated and controls the outflow valve. After confirmation from the pilot flying, clear cabin pressure. Clear cabin pressure. The status page is now displayed. There are no approach procedures to follow, and the inoperative system is Cabin Pressurization System 1. Once both pilots have reviewed the status page, clear the status page. Clear status. The status page is replaced by the cruise page. We have now completed the ECAM procedure for a Cabin Pressure System 1 fault. Let's look at a second failure to illustrate the functionality of the system, the associated indication, and the ECAM procedure. We will use a dual system fault to illustrate these procedures. The aircraft is in cruise at flight level 350. The ECAM system has generated a failure message with action lines and called the ECAM cabin pressure page. Read the ECAM failure title and on the ECAM cabin pressure page observe the indications shown in amber. Read and complete the action items on the engine warning display. In this case, both automatic systems have failed. We must switch to manual mode. Notice that the mode selector switch has an amber fault indication to help you locate it. Switch to manual mode. The indication on the switch changes to show manual in white, and a green manual message appears on the system page to indicate that the pressurization system is in manual mode. You must now control the pressurization of the aircraft by using the manual vertical speed control switch to move the outflow valve. Notice also that, since you have control of the outflow valve, the landing elevation indication is no longer displayed. Let's pause the ECAM procedure and look at the use of the manual vertical speed control. The manual vertical speed switch is spring-loaded to neutral. If you hold the switch in the up position, the outflow valve slowly opens, the vertical speed will change, and the cabin altitude will increase. When the manual vertical speed control is returned to the neutral position, the outflow valve will stop moving. The vertical speed will stabilize and the cabin altitude will change. Conversely, if you hold the switch down, the outflow valve will close, the vertical speed will change, and the cabin altitude will decrease. Now let's return to the ECAM procedure. Notice that the vertical speed indication is 0. This means that, as we are in cruise, there is no need to adjust the outflow valve position using the manual vertical speed control. Because you have to continually use the manual vertical speed control switch, the action line is not removed. Clear cabin pressure to review status. Clear cabin. The status page provides the pilots with information: target vertical speeds, target cabin altitudes, which depend on the flight level, and a final approach procedure to set the vertical speed control fully up. This ensures that the outflow valve opens completely and the aircraft depressurizes. For our example, we are at flight level 350, so the target cabin altitude is 6,500 feet. View the inoperative systems in the right-hand column. Remember that information will remain on the status page for the duration of the flight and can be reviewed at any time. The information on the status page is very useful during descent. You will need to control the outflow valve and adjust the cabin vertical speed to achieve the target cabin altitude. After confirmation from the pilot flying, clear status. Clear status. Notice that on the cruise page, the indication of cabin vertical speed has changed to a gauge format. This, along with the cabin altitude indication, can be used to set the correct position of the outflow valve. The ECAM procedure for a cabin pressure system 1+2 fault is complete. Let's now assume that ATC have asked you to commence a descent to flight level 290. Call the status page. Note that the target cabin vertical speed for the descent is 300 feet per minute, and that at flight level 290, the cabin altitude target is 4,500 feet. Deselect status. The descent has been started. The manual vertical speed control should be selected to establish a cabin vertical speed of 300 feet per minute down. Select manual vertical speed control. The switch is held down until the cabin vertical speed reaches the target of 300 feet per minute, and then released back to the neutral position. The cabin altitude is now decreasing. Approaching the target cabin altitude, the manual vertical speed control is selected up to decrease the cabin vertical speed. Some fine-tuning may be required using short blips of the manual vertical speed control. You will have the opportunity to practice the use of the manual vertical speed control in the simulator. So we will stop here. In this module, we will look at some other abnormal situations of the pressurization system. This is an example of an abnormal procedure. The aircraft is in cruise and all systems are working normally. The caution landing 11 fault is telling you that the pressurization system has, for some reason, lost the landing elevation data normally supplied by the FMGS. Notice that the landing elevation details on the system page are blank. Read and complete the actions on the engine warning display. In this case, we have to set the landing field elevation manually. Select the landing elevation selector. As soon as the selector is moved from the auto position, the action line on the engine warning display clears and a manual message appears on the cabin pressure page. The landing elevation value will also indicate the selected value. After confirmation from the pilot flying, clear cabin pressure. Clear cabin pressure. Notice that there is no call of the status page because we have set the landing elevation manually and the system is operative. There is a manual landing elevation indication on the cruise page. The ECAM actions are complete. To complete this module, let's look at some other abnormal indications and what they mean. If there is an excessive positive or negative differential pressure, one of the safety valves will operate. An ECAM caution, cabin pressure safety valve open, is generated and the safety valve indication on the cabin pressure page changes to amber. An ECAM caution, cabin pressure outflow valve not open, will be displayed if the outflow valve has not fully opened on landing. This could mean that the aircraft is still pressurized and the doors will be difficult to open. Indications on the cabin pressure page will change to amber for abnormal indications apart from the cabin altitude. If there is an excessive cabin altitude, the indication turns red and a master warning is generated.